I'm usually used to being like the loudest person in the room. I think my indoor voice is my outdoor voice, so it's the same voice basically. So yeah, my talk today is going to be on data flow in JavaScript applications, but mostly also kind of taking a look at design patterns, taking a look at a couple different ways we would do data flow in a JavaScript application, and understanding the history from some of these patterns, looking at how we get to Redux from maybe looking at PubSub and where you can go from there. So a little bit about me. My name is Christiani. I'm from Canada. You can follow me, rChristiani, on Twitter if you'd like. You're going to see some hot tweets like this one. Praise to those who clean the lint trap, skull to those who don't. If you live in a rental apartment, you got to clean that trap. Come on. Also like this, just a general thought, how good is coffee? No? It's OK. I am actually, so when I submitted this talk, I was the head instructor and development lead at HackerYou, but now I got a promotion. I'm the CTO at HackerYou now, so that's pretty cool. We are a Toronto-based boot camp. I don't know if there's, or if you know what this idea of a boot camp is, but basically we take students from week 1 to the end of 9 weeks, and we teach them what they need to know to get started in a career as a developer. So we focus on front-end development. We spend 6.5 weeks on JavaScript. We teach React and stuff like that. Yeah, so I'm from Toronto, but it's pronounced Toronto, no T at the end there. Back in January of 2016, I started this little video series on YouTube called Let's Learn ES6, and it turned into a book, so you can check that out. Actually, if you follow me on Twitter, you can get a 50% off discount code for that. I also do this video series called Let's Code Along. You can see me over here, this tiger. I mean, it's the guy over there with the pants on. I was trying to think if I should wear this look, but it was too hot, so I wore my best jorts today instead. Should I have done the pants instead? Oh, OK, well. Maybe should we stop here and I'll go get mine from the hotel? Anyways, what we're going to talk about today is what is a design pattern. Explore some common patterns if you're a JavaScript developer you might not have known you were using as a pattern. We're going to look at PubSub, we're going to look at Flux, and we're going to look at Redux. If you are not a JavaScript developer, that's OK, because there's still a story here for anything we're doing in terms of development or design or anything like that. So what is a design pattern? How many people have heard of this idea of a design pattern before? A couple people. Cool, actually more than I thought. Cool, so a design pattern is a reusable solution to a common problem. So there's this quote here, each pattern describes a problem which occurs over and over in our environments, and then describe the core solution to this problem such that we can use it 1,000,000 times over without ever doing the same way twice. So this was a quote from a man named Christopher Alexander, and he's actually an architect. So he wasn't, at this time in the 60s, a developer, but he was an architect. And if you can imagine, in architecture, especially like architecture like this, there's a lot of common patterns we do over and over again. So his idea, his pattern language movement that he started, actually started to influence programming languages in the 1960s and beyond. And patterns, again, really help us identify problems and help us pick appropriate solutions to these problems from like a trusted catalog of abstractions. Again, could be in programming, could be in architecture, could be in design. We see this, and I think a couple talks just before mine, we were talking about design patterns. Material design, for example, is a design pattern. So here's a really good quote or example. For instance, in Alexander's work, bus stops and waiting rooms in a surgery center follow the context for the pattern, a place to wait. So there is a pattern there. There's a kind of catalog you pull from. Has anybody seen this book before? No? A couple people. So this book's called Design Patterns, Elements of Reusable Object-Oriented Software. It's commonly referred to as the Gang of Four book, basically because it was written by 4 people. But this kind of got into print, got onto paper, a lot of design patterns that were being used in software. It was printed in 1994, and a lot of these patterns are still in use. So if you want, I highly suggest picking this up. It's actually a really, really good book. It's sort of like a required reading for design patterns. The book breaks these patterns into 3 categories. So there's the creational patterns, so stuff like factory pattern and the singleton pattern. There's stuff like structural patterns, stuff like the facade. How many people have used jQuery before? So jQuery is a huge example of the facade pattern. Basically, you do something like .add class to add a class to something, but in reality, there's a ton of things happening there that we do not see. There's a facade in front of it. Another example would be something like the decorator pattern, and behavioral patterns is the third category. And the observer pattern, which we're going to kind of look at a slight variation on, is one of those. So the examples in that book, however, are in C++ and Smalltalk. So if you can't really wrap your head and reason about those, there is a really great book by Adi Osmani called JavaScript Design Patterns, which takes a lot of these patterns and a couple ones that are specific to JavaScript and breaks them down for you to read. So highly suggest getting this. And in fact, you can buy this book on O'Reilly, or it's just free online. So if you wanted to do that, you can go ahead and grab it. Just search Learning JavaScript Design Patterns. So let's look at a couple examples of patterns that you might not know you've been using. How many people have ever written code that looks a little bit like this? No, nobody? Cool. Well, where I work, where we teach students, this is something we show our students fairly early on, because as you're starting to learn JavaScript and then as we kind of progress, your code has to get bigger and bigger and bigger. So we use this kind of namespacing pattern to organize our code a little bit better. We have something like an app object where we can kind of apply our properties and methods to. Really, it allows us to just simplify our code and prevent sort of spaghetti code from happening. It solves a couple really simple issues for us. Prevents the issue of name clashes, so you should always think about the fact that your code is not the only code or they're not the only JavaScript running on the page, so you want to try and contain that. And we do that by preventing the pollution of global scope. Introduce one app object and let everything else kind of live inside of that. And then, of course, it's a solution to spaghetti code. Here's a pretty common one that I think now that ES6 modules are out, less people will be using this for the purposes of using it, but the module pattern. Basically, we have a little person here. There's a function that wraps it. Inside of it, there's a variable called age, and then it returns an object. What this pattern lets us do in JavaScript is produce this idea of privacy. We didn't have this ability in ES5 and before, but using this pattern and through the power of closures and functions, we can actually get this to do what we want. So the idea is that you kind of create this privacy, but implement the interface, the object that you want to interact with after. So if you take a look again, you can see where it says let age. That would be private inside of this, but the returned object is this public interface that we get to work with. So again, it allows us to create privacy and allows us to define our interface. So those are some examples of patterns if you've been writing JavaScript, even a little bit of JavaScript you might have seen from time to time. But let's talk about managing state. How many people have seen It's Always Sunny in Philadelphia? If you haven't, this is another good reason to follow me on Twitter. Probably in about a minute, I'm going to auto-post the video that goes behind this. So funny. But managing state in our applications can be kind of frustrating, right? It's kind of like a Pepe Sylvia crime wall situation. Basically, if you've ever been, when they're in a crime series, they go into the serial killer's apartment and there's red twine. Actually, I guess it's the other way around. They're trying to find the serial killer and they just have red twine everywhere and they're like, this person's connected to this person. It can kind of feel like that when you're managing state in your application. So let's look at the pub sub pattern. So this is a variation, a popular variation on the observer pattern. I didn't want to show the observer pattern because there's a lot more to it, and I want to kind of keep this as kind of easy to understand as possible. It's a very simple kind of event system. It allows us to create our own events. So what it really is an object that has two methods for us, a subscribe and a publish method. And the idea is that we can publish actions or events, and we can subscribe to those actions or events from anywhere in our application. So clicking a button could publish something, maybe some sort of counter could listen for when that has been clicked on. There's going to be a bunch of code here, but again, don't worry too much about the code. Worry about the idea. So here's the publish method. It's actually very simple, because I'm going to show you another method, and that's it for pub/sub. But the publish method takes an event, it takes some data, and basically looks through a listener object. If that thing existed in there, if that event existed in there, run the function for it. If not, no big deal. The subscribe is sort of the same. You take an event, and you take the function to actually be run when this happens. So, OK. This is an amazing demo, so hold on, wait for it. Are you ready? No, it's okay. There's like 2 more of these, and you're going to have so much fun at the end. Basically, you click on the add button there or the subtract button, and it's just publishing an event. I have to click back over here to get it to go again. Boop. So if you hook it up, this is the kind of nice thing. We can hook up something to subscribe to the increase event. And when some data gets passed to it, we can do whatever we want with it. And when we click on one of those buttons, we could publish, an event. So in this case, an increase event could be a decrease. It could be actually whatever you want. You can come up with these names, and you'll hopefully see the path we're going on here. So you publish an event, and anything subscribed to it will listen and then update. So what is the core concept here? Well, it's starting to allow us to register components specifically to events, and more importantly, it's starting to allow us to decouple the data from our views. I see a lot of our students writing JavaScript where, inside of this function, it does the same thing as that function, just to get the same data they want. But if you have this sort of system in place, you can start to decouple that information. How many people have heard of Flux before? So Flux is a really popular pattern introduced by Facebook. I think it was like 2013, I think. And it solved a pretty famous problem for them. If you were ever, and here's the video, I'll post the link to the slides later, but they described the problem in this video, but I'm pretty sure I remember seeing this, that in the top right-hand corner of Facebook, there's like a little jewel that they call them that are like your notifications, and when they started to introduce messages, your messages, the data had to be registered in this thing, it had to be registered in your messages, and then on the big view for all your messages, so there's like 3, 4, maybe 5 places that, hey, you have a notification, had to be registered. And if you think about Flux, Facebook, it's a really, really huge application, and you're going to have a lot of JavaScript. And if you have to kind of change your JavaScript code in all these different places, it's going to be a big problem. One thing I actually really want to point out is that although Flux is famously used with React a lot, Flux can be used just with anything. The example I'm going to show you, another amazing example, will actually have no React in it at all. So it promotes this idea of a single directional data flow. So the idea is going to be that we're going to dispatch actions to stores. So Flux actually introduces a couple of things here. So we had a publish and a subscribe method on our pub sub object before. Now what Flux does is introduces a stores and an actions and a dispatchers kind of idea. The dispatcher, again, think of that as the publisher. You're publishing some sort of event or dispatching some sort of action. So again, the idea is you dispatch actions to your stores, and then any store listening to it, any component listening to it will handle the data change. So it looks like this. Dispatcher goes to the stores. Stores will make the data change. That will go to your components. Everything will update. Pretty cool. And then maybe somebody initializes a new action, and then I don't have a loop, but it loops back around. So now, if everything is listening to this store, you have this great way to make sure that everything is updated. So one of the really cool things that Flux introduced was this idea of stores. There are multiple stores in Flux, so you could have a store for a counter or messages, you could have a store for new feed items, you could have a store for, whatever you wanted to. Fruit, I guess. It's a fruit store joke. Groceries? No? It's okay. There are many stores in Flux, and you have to implement your own. But again, we're taking this data out from our components and just kind of putting them into one central or many central places. So a really quick example is a classic way to implement a store with in Flux would be using Node's event emitter and using ES6 classes to just extend it. Basically, here we're just saying, use the event emitter. It's a really easy way to sort of just create our own events and admit an event, so publish an event, and set up a counter value inside of our store. So again, it allows us to sort of decouple our information. So it actually maybe still looks a little bit like this because there's multiple stores, but we're getting rid of that frantic guy who's just not sure where everything's going. There's still this kind of structure. Again, to have this actually work, you could dispatch an action. Again, think publish an action. You could have something subscribe to when that store changes and get that data back. And of course, you have to register something there if you wanted. You have to register your action handler. So what is going to happen actually when that action occurs? So with the pub sub pattern, you just kind of get the data and do what you want. But now with Flux, and we'll see this again with Redux, we actually have to figure out how to handle this flow for everything, how to handle this data change for everything. So in this case, we take an action, and if it's an increase, we want to add to the count. If it's a decrease, we want to remove from the count. And then there's a fun face if it's a default. Handling the action change is up to us. So in our case, what we're doing is we're simply increasing the counter and then saying to everybody, so we're admitting here, hey, we changed something. So anybody listening for that change is going to get updated. Right? How many people got really excited when they saw this? They're like, this is going to be, what if it did something completely different? I was toying around with, like, you'd click the button and then, like, something else would happen, but got to stay true to myself, you know? Anyways, another example. The whole point of these examples is that when I show you or release the code on Twitter, you can actually take a look at the 3 examples. There's a pub sub Flux and a Redux example. They all do the same thing, though. That's the idea there. So all actions, anytime you click on something, anytime you dispatch an action, all actions are passed to all of our stores, which is kind of nice because if we have multiple stores, we might want to have specific actions work on maybe potentially multiple things. Again, now we're getting to this idea of breaking out our data, and it helps us like loosely couple our system. Instead of everything being tightly wound up together, we're breaking it apart a bit. So an interesting idea here is that now that we're kind of looking into this more, this introduces this idea of the law of Demeter, also referred to as the principle of least knowledge. Basically, it's a decoupled system really embodies this idea. And I like this as a way to think about it. It's like only talk to your friends. So in that kind of system, objects should only talk to their friends and not their friends of friends. Slightly antisocial, so like maybe you've gone to the bar, you talk to like your one friend, and you're like, I'm going to go home and go watch some Netflix. But the idea is you're not spreading yourself too thin. You're kind of keeping it really tight. So then we have Redux. How many people have heard of Redux before? Cool. So Redux is super popular. Again, really commonly used with React. But really importantly, you don't have to use it with React. Again, the example I'll show you, no React at all. So what Redux does is it takes that Flux idea and actually introduces a few new things and changes some others. So one of the key changes is that instead of having multiple stores for all of our data, we have one store and all of the data lives inside of there. So it introduces, instead of these action handlers, this idea of a reducer. And the reducers are the things that decide how we'll change our data for that whole store. Again, one big store for everything. So the reducers take all of the actions and allow us to decide how to change our state based on them. And the store is now just one simple object. So instead of having many objects, so if you remember, again, we went from just sort of being able to publish and subscribe something to subscribe to something. Then we went to this idea of being able to subscribe, but we're dispatching actions that are changing the data for us. And we have these stores that hold the data. Now, with Redux, we have one store and reducers that handle that change. So now we're actually really getting into that single line of information. No? I mean, I put it on brand. It's like the purple color. Where's my mouse? It's really hard to see. Right? Thank you. Thank you. I was really worried that you would not find those enjoyable as I found them to make. So again, a reducer kind of looks like our action handler. So if you take a look at this code, and if I go back quite a few here to our action handler, it looks very similar. So this is an action handler. You take an action, you decide what to do with it. In this case, deciding what to do with it involves calling functions, calling different methods on our store to do what we want. If we go back to the reducer, what we have is a function that takes state, actually, and the action. So with the reducer, you take the state as it is. So up here, again, we have state equals 0. That's a default property with ES6. You should probably follow me on Twitter so you can get that discount code. Pretty cool. Anyways, you take the action, and then we return the state. So the really cool thing here is instead of calling other methods, other functions for this, we just return the state how we expect it to be. In this case, we're doing a really simple number. We're just changing it, increasing it by 1, up or down. But if you had a large set of data, objects or arrays or whatever, you could do all that stuff in there as well. So to create the store, so unlike Flux, Redux actually allows us, or gives us this ability to create the store. It has all of that stuff written for us. And stores have 3 methods on them. But let's look at this. There's a method called dispatch. Maybe think publish. There's a method called subscribe. Well, think subscribe. And then there's one method called getState. GetState is basically how we can just get our state. And that's, again, getting that single object state. So you dispatch an action, and you pass it some data or a payload or something like that. And then you can subscribe to anything that you want. So in our case here, we're not using React here. So we don't have like any fancy Connect middleware or anything like that. We just simply have the App Store. We subscribe. And notice we don't even subscribe to a specific event here. If you notice in the slides before, there was like counter store, on change or something like that. And we had to say what event we wanted to subscribe to. In this case, we're just subscribing to everything, and we can get the state for it. So again, as we've kind of like been exploring these, or when I was writing this talk and exploring these, you start to realize that all of these things sort of build on top of each other, and all of these things include ideas, and actually maybe introduce new things to you. So one of the really cool things that Redux introduces is this idea of immutability. When we alter our state, inside of a Redux reducer, we never want to mutate the original object or array or value. We always want to return a new copy of it. This is really helpful for debugging later on, but this introduces this idea of immutability and pure functions. How many people have heard of this idea of a pure function before? Cool. So pure functions are functions that functions that have no side effects. So you can pass them some values, and they'll predictably always return you the new thing, always the exact same way. The idea being that if we pass it an array or an object, you might actually alter that, and then it'll alter that object if somebody else is using the exact same object somewhere else to an undesirable state. So a pure function would create a new array or an object from the passed data. So really easy example of an impure function would be something like this. Let total equal 0, and then you have a function add that takes a and b, but inside of add, we make total equal that a and b. Really, really simple thing. And again, when I'm teaching students, this is something that comes up a lot. This is something that happens a lot. But in this case, you're changing total, and somebody else could be using total and not have it what you expect it to be. In this case here, we have a function. It takes a and b, but it returns a new value, a plus b. So this would be considered a pure function. We could pass numbers to this all day long, and this wouldn't change our code. So that's what we do inside of reducers. When we have some sort of action that comes into it, we always just return something new. In this case, we've just done a simple number, but if you had an object or an array or something like that, you would always want to make something new from it. So for arrays, maybe array from, or you're slicing it. For objects, object.create. You always want to return something new. The core idea here is that pure functions help us write maintainable and predictable code. So in this case, and in the case of Redux and managing our state, we want to make sure that we can always predict where it's going to be. And the really cool thing about this is because we have these new versions of it, we can see the old versions. So with Redux, you can always use the time traveling feature in it to actually see how your application has worked over time. So when I was actually reading the docs for Redux, I came across this thing that they have in there called prior art. So if you actually look at the documentation, there's a prior art section for Redux where they kind of go through, so Dan Abramoff goes through sort of the places that Redux came from, the ideas that kind of like drove Redux. Flux is sort of talked about there. He also talks about like Elm. Elm is a really big driving point for stuff in Redux. Mutable.js, and there's a couple other things that I had never heard of before. But if you think about it, these ideas, this idea of Redux, for example, didn't just come out of nowhere. These weren't like completely brand new ideas that were just like one day someone's like, this is how it's going to be. No one's ever done it like this. There's a bit of a history to it. There's a bit of a prior art to it. Has anybody seen this episode of Futurama? It's probably my favorite. It's the one where Fry drinks 100 cups of coffee and then he stops time for a second. No? You definitely watch that one. So quick recap, a little bit quicker than I thought here, but patterns are everywhere. You might not see them now, but as you kind of build applications more and more, you'll notice you keep doing the same things over and over again. And you might want to consider, hey, is this a good pattern, first of all, or a bad pattern that I keep using? And in our case, we looked at how the pattern of PubSub, Flux, and Redux have this similar lineage, this similar history with them. So take a deeper look into these ideas and where they come from. Again, go check out the Redux documentation. You can see the prior art section. You can see where these ideas came from. And you kind of reading that and exploring that more might help you come up with a new great idea. Yeah, you might learn a thing or two. Thanks. Yeah, so there's a little bit of extra time because I am super fast at talking. So if anybody has any questions, please let me know. Yeah. Oh, hold on one second. Let him.
All right. So is this based on functional programming?
Sorry?
Is this functional programming?
So I think a lot of the ideas of immutability is functional programming, where you're kind of constantly just taking data and like changing it, transforming it. But it's not necessarily functional programming, like the data flow. A lot of the stuff you do in Redux is more towards functional programming, yeah, but PubSub not so much, and so on. Yeah. Any other questions? No?